Imagine you're an astronaut in the velvet black of space. And there it is, a patch of perfect darkness, a literal hole in the fabric of the universe. It's pulling at you, not just with its incredible gravity, but with a question that pushes physics to its limits. Could we actually live in there? We're going to explore that cosmic question and the terrifying science that reveals why any journey past the event horizon is a one-way ticket. Forget finding a new home on Mars. We're talking about setting up shop inside the universe's most extreme object. It sounds like science fiction, but understanding what truly happens inside a black hole is a major focus in physics today. Is it a secret gateway to another universe? Or just the most violent, inescapable death trap in existence? The truth is weirder than you can imagine. So, what is this thing? A black hole is what's left when a massive star dies and its core collapses under its own weight. Imagine the mass of our sun squeezed into a space smaller than a city. The result is an object so dense, its gravitational pull literally breaks space-time. If you think of space-time as a rubber sheet, a planet creates a dip, and a star a bigger one. But a black hole isn't a dip. It's a puncture. It's a point of seemingly infinite density, where our laws of physics completely fall apart. What we call the singularity. Wrapped around this is the event horizon. This isn't a physical wall, but an invisible boundary. It's the point of no return where gravity is so strong that you'd need to travel faster than light to get away. And since nothing can, anything that crosses it is trapped forever. Let's begin our trip. As you get closer, the black hole's gravity acts like a lens, warping starlight into strange rings. If the black hole is feeding, it will be surrounded by an accretion disk, a white-hot whirlpool of gas and shredded stars, blasting out lethal radiation. We'll have to pretend your ship is indestructible. As you approach the event horizon, a strange effect called time dilation kicks in. To your friends watching from a safe distance, your ship would appear to move in slow motion, getting dimmer and redder as it nears the edge. They would never actually see you cross. You'd look frozen for an eternity, slowly fading from view. But for you, time would feel completely normal. Looking back out, however, you'd witness the entire future of the universe flash before your eyes in the moments before you slip across the boundary. And now, you've crossed the event horizon. What happens next depends entirely on the black hole's size. If you fall into a small, stellar mass black hole, your end will be quick and gruesome. The difference in gravity between your head and feet, known as tidal forces, would stretch you into a long, thin strand of atoms. Scientists have a grimly fitting name for this: spaghettification. You'd be shredded before you even got inside. But if you aim for a supermassive black hole, like Sagittarius A star in our own galaxy, it's a different story. It is so enormous that the tidal forces at the event horizon are gentle enough that you could drift across completely unharmed. No jolt, no warning. 1 second you're outside, the next you're inside, having passed the point of no return. So, we're inside. Can we establish a base here? The answer is an indisputable no. Once you cross the event horizon, the singularity is no longer a place you can avoid. It becomes your future. Every possible path, forward, backward, left, right, inevitably leads to the center. Trying to fly away from the singularity is like trying to travel back in time to last Tuesday. It's simply not possible. The time you have left depends on the black hole's mass. For a supermassive one, you might have minutes or even hours, but that time is finite. You are on a one-way conveyor belt to oblivion. There are no stable orbits inside a black hole. There is only the fall. This relentless push into the unknown is what science is all about. If you love exploring the biggest questions in the cosmos, from the nature of reality to the search for alien life, you're in the right place. Make sure you're subscribed and have notifications turned on so you don't miss our next journey to the frontiers of science. So what happens when your time finally runs out? You arrive at the singularity. According to Einstein's general relativity, the singularity is a point of zero volume and infinite density, where all the black hole's matter is crushed into nothing. At this point, our understanding of physics completely shatters. Most physicists don't believe a true, infinitely dense point exists. They see the singularity as a sign that our theories are incomplete. We need a new theory that can unite gravity with quantum mechanics. These emerging ideas suggest the center isn't a point, but perhaps a Planck star, an object so incredibly dense it resists any further collapse. But even so, the conditions would vaporize any form of matter. The fact that we can't live inside a black hole leads to a truly mind-bending idea. Some physicists have noted that the density of our observable universe is surprisingly close to the density of a black hole of the same size. This has led to a speculative theory called black hole cosmology, the idea that our entire universe might actually be the interior of a giant black hole that exists in a larger parent universe. In this scenario, the Big Bang was simply the formation of the black hole we now call our universe. It's a fringe idea, but it's a powerful reminder that reality is likely far stranger than we can possibly grasp. So, could we really live inside a black hole? The science is crystal clear, not a chance. Between lethal radiation, body-shredding gravity, and an inescapable trip to a point where reality itself breaks down, a black hole is the most hostile environment in the cosmos. It's not a home, it's a prison from which you can never escape, where your sentence is a final countdown to zero. But the quest to understand them pushes us to the very limits of our knowledge. They are cosmic laboratories for testing the laws of gravity and space-time, and they might even hold the keys to understanding the birth of our own universe. They are a terrifying and beautiful reminder of just how much we have left to figure out. What mystery do you think black holes are still hiding? Let us know in the comments.